All right, we're going to look at some shifted conic sections. We're going to start with shifting parabolas. So parabolas was one of the first conic sections that we looked at. So first we're going to talk about the equation that we're used to seeing versus the new shifted equation. So our typical one before, we had y squared equals 4px. And this was if we had a horizontal parabola, and I know it's horizontal because x is my normal variable. And then the other one was x squared equals 4py. And this is the equation of a vertical one because the y is my normal variable. So with my shifted parabola, I have y minus k inside parentheses squared equals 4p and then x minus h. So what got added is this k and this h, and that will tell you how much you're shifting it. Whatever is next to the x is going left or right, and then whatever is next to the y is up or down. And then for this one, it would be x minus h inside parentheses equals 4p and then y minus k. So the h is always by the x, you'll notice in both, and then the k is always by your y. So if h is negative, that means my parabola is getting shifted to the left. If it is positive, it is getting shifted to the right. If k is negative, it is going down. If it's positive, it is going up. A big thing about noticing if it's going to be negative or positive, it's actually going to look like the opposite when it's in the equation, because if my k value is positive, it's going to look like it's subtracting. So it's going to look negative, but we know it's actually the opposite. So very similar to when we did transformations. So I'm going to scoot this up a little bit. So we're going to go through these examples. I am going to start with example 1. So I have this equation. So I have my template up above, but I also have my formula sheet here. So I am going to look at, for my parabolas, does it match the template for a horizontal or a vertical? So when I'm looking at my equation, I notice I have x minus 2 raised to a power of 2. Well, this is y minus something with an exponent. This is x minus something with an exponent. So I know it's matching this one. So I know I'm going to be working with vertical. This is going to be a vertical parabola. So I'm going to kind of go like this. So I'm going to make a note of this. It is vertical, so I'm going to circle that. I want to try to find my p value. So my 4p is whatever's in front of my parentheses here. So I know I can say 8 is equal to 4p and solve this. So I get 2 equals p. That's important because that is what my focus is based around, my directrix, and my focal diameter. So my vertex is my h comma k. So in my equation, my h is 2 and my k is 3. They're both positive because it's x minus whatever my h and then y minus whatever my k is. And so even though they look negative, they're actually positive. So my new vertex is going to be 2, 3. That is telling me that I'm going right 2 units and up 3 units. So I'm going to move my formula sheet. So now I want to figure out what my original focus was. Well, my original focus is 0, whatever my p value is, and I found my p value was 2, so 0, 2. My original directrix is y equals negative p, so y equals negative 2. And then my focal diameter is the absolute value of 4 times p, so the absolute value of 4 times 2, which is 8. So that's all of my original stuff, and then what I want to do is figure out what is my new focus and my new directrix. We already got our new vertex written here, so we only need to find 2 more things. what I want to do to find my new stuff is I'm going to take my original and I'm going to add my new vertex to it. So I'm going to do my original, so I'm going to do like 0, 2, and I'm going to add on to that 2, 3. So I took my original focus, which is 0, 2, and I'm adding onto it my new vertex. And so what that gives me is going to be, well, my x values, 0 plus 2, go like this. So I add those and I get my x value of 2. And then 2 is my y value plus 3 is my y value, which is 5. So my new focus is 2, 5. For my original directrix, I have y equals -2. It's still going to be y equals. And then since this is a y value, I'm going to add my y value from this point onto it. So I'm going to do -2 plus 3, and that will be my directrix. So that will give me y equals 1. So now I have enough information where I can go ahead and sketch it. So I'm going to put my x-axis a little bit lower since I know it got shifted up. All right, so my new vertex is at 2, 3, which is here. My new focus is at 2, 5. My directrix got shifted to y equals a positive 1. So it crosses the y-axis at 1. And then my focal diameter is 8. So through my focus, parallel to the directrix, I am going to go 4 each way. So 1, oh gosh, 1, 2, 3, 4, about there. That's the closest I can get. So then my graph looks like this. And I have my, parabola that was shifted. I'm going to go ahead and label my directrix. We did our first one. So for example 2, it's a little different because I don't have 2 sets of parentheses. So when I look at my formula sheet, it doesn't look like it matches either one. So what I have to do is factor out my GCF of the right side. So I'm going to make a note here. And I want the GCF of -6x plus 8t. So the GCF of that is going to be -6, so I'm left with x minus 3. So now I can go ahead and figure out a couple things. Looking at my formula sheet, when I look back here, I do have y plus 1 in parentheses squared, and so it looks like it's going to match this template, so it's going to be horizontal. So my original vertex is 0, 0. My original focus is based on my p-value. So again, I take my -6, so the number that's in front of my parentheses, and I'm going to set it equal to 4p. And I'm going to get a decimal, and that's okay. So I get -1.5 equals p. So looking at my formula sheet, I'm gonna scoot this over a little bit, and then we can see it over here. So my focus is p comma 0. Well, if my p-value is -1.5, I have -1.5 comma 0. My directrix is x equals -p. Well, if my p is already negative, 2 negatives make a positive. And then my focal diameter is the absolute value of 4 times negative 1.5. Well, we know that is negative 6, but the absolute value of negative 6 is 6. Then to find my new information, I want to find my vertex. So my vertex is my h and my k. So my h in my equation is 3, and my k is a negative 1. So that's this one, but it's the opposite of what it looked. So if it was y minus a negative 1, it would look like addition, which is what we have. So negative 1. So now I'm going to move my formula sheet away. To find my new focus, I'm going to take my original focus and add my new vertex to it. So I'm going to do original focus plus new vertex equals the new focus. So I'm going to add my x's. Negative 1.5 plus 3 is going to be a positive 1.5. 0 plus negative 1 is negative 1. For my directrix, since it's the x value, I only add the x value to it. 1.5 plus 3 is 4.5. So now I can go ahead and graph my shifted parabola. And I'm just looking at how far I should go in either direction for my tick marks. So we're going to go 5. Oop. So we have our new vertex, our new focus. 4.5 is like here, so this is our new directrix. And my focal diameter is 6, so I'm going to go 3 in either direction. 1, 2, 3, 1, 2, 3, like there. I don't think my spacing was that accurate, but that's okay. And then, oof. This one's a little wonky, but it works. I realize my focus is a little bit too close to 1 instead of 1.5. It's a sketch. It's close. So now we're going to look at a couple examples where we're not trying to sketch it. We're going to be actually writing the equations once we are given information. So if we have our new vertex, that will tell us how our parabola has been shifted, which means we can go back to our original focus or anything like that, which can tell us our p-value, which we need to write our equation. So we have to write an equation of a parabola that satisfies a focus at 3, 6 and a vertex at 3, 2. Right off the bat, I'm going to go ahead and label my vertex as h and k because I'm going to need h and k in my templates depending on if it's going to be vertical or horizontal. What I like to do is kind of sketch a quick little, so 3, 2 is there, and then 3, 6 is here. So what I'm going to do is I'm going to kind of work backwards. If my vertex is at 3, 2, I'm going to go back and go down 2 and left 3 would get me back to my original vertex at the origin. So I'm going to do the same thing to my focus. I'm going to go down 2 and then left 3. So 1, 2, 3. So this right here would have been my original focus. So that point is 0, 1, 2, 3, 4, 0, 4. So my original focus was at 0, 4. So as of right now, I do have enough information where I can write the equation because if my original focus is 0, 4, when I look at my formula sheet, well, the focus that is written as 0, a number is when it is vertical. So that tells me which template to use for my equation. And that also tells me that my P has to be 4. So I'm going to make a note here. So this tells us it is vertical and that P equals 4. So for a vertical shifted parabola, this is our template. So I'm going to go ahead and write this on our notes. And then I fill in what I know. So I know that my H is 3. And then my P is 4. And my K is 2. So I plug in what I know. I can go ahead and simplify this. Well, 4 times 4 is 16. And then I leave it to match the template. So I don't need to distribute the 16 into the y minus 2. I have my equation. I am good. We're going to do one more. So example 5 is very similar to example 3. Example 4, we have a picture. So you want to be able to identify things from the picture. So we have our new vertex, which is this 2, 3. We have our new focus, and we have our new directrix. So we're trying to find the equation for this. And to do that, we need to figure out what our P value is. So I'm going to work backwards just like I did with the 1 in example 3. So if my original vertex was at 0, 0, I went to the right 2, and then I went up 3. So I noticed that my scale's a little off. Oh no, I'm silly. This is my origin, not this. So right 2, up 3. So to work backwards, I'm going to go left 2, down 3, I would get back to my vertex, my original vertex. So from my focus, I'm going to go left 2, down 3, which would be right here, and this would be my original focus at that top red dot. That dot is 0, 2. So over here, I'm going to say my original focus is 0, 2. Now, I could have looked at this picture and seen that it was vertical anyways. If I didn't do that, how my focus is written also tells me that it's vertical. So we know it's vertical. We know our P is 2 because that was our original focus. So I'm going to have the same template as before. And I want to plug in what I know. I know my P, my H, and my K are part of my new vertex. So my H would be 2 and my K would be 3. So I have X minus H, which is 2, equals 4 times my P value, which is also 2. And then Y minus K, which is 3. So when I simplify this, the only thing I want to simplify is my 4 times P. So 4 times 2, which is 8. And then we have Y minus 3. And we have our equation. And we did it!